4.5, this is our third video on 4.5. We're going to talk about slant asymptotes today. So we're still dealing with rational functions, but we're going to deal with slant asymptotes. So how do you graph rational functions with slant asymptotes is your essential question. I'm going to start with the fact that you are given some function f of x, and that function is some numerator polynomial over some denominator polynomial. And what we've been doing in this lesson, in your previous lessons I should say, is that you've been using synthetic substitution to write this as a mixed number. So this could also equal some polynomial plus the remainder over the denominator polynomial. Well, here's the thing. P of x is what we want to focus on. Now, in all of the problems that you've done so far, P of x has become a constant, and you've just had horizontal or vertical asymptotes. Well, what if this is not a constant? Well, if it's not a constant, then you're getting some kind of polynomial. We'll call that y equals P of x. And that's going to be a non-vertical asymptote. So it could be a line, maybe a diagonal line. It could be a parabola. It could be a whole bunch of different things. Okay, so that's what we're going to explore today. And I'm just going to do a couple problems out of your book. So your examples are going to come from the evens. They're going to be on page 219, and our directions are just going to be to graph. Now, the directions in the book are, A, do this, B, do this, C, do this, but eventually it's all leading you to graph, so I'm just simplifying the directions. Okay, so these are our examples. So the first one we're going to do is number 24, which looks like this. So the first thing I want to do in order to graph this is I want to use synthetic division or synthetic substitution. So you get 1 on the outside, and you got 1, negative 6, and 8 on the inside. Okay, so I end up with this remainder of 3. So really what I have now is that f of x as a mixed number can be written as x minus 5 plus 3 over the denominator, which was x minus 1. Okay, so this right here is going to be our slant asymptote. Okay, so let's get a graph going here. I'm going to use a ruler to try and be neat. Now, the rest of everything still stays the same. You're still going to have a vertical asymptote where your denominator becomes 0. So my denominator will be 0 at when x equals 1. So I've still got that vertical asymptote. This is at 1. But now I'm going to have this other asymptote. The equation, basically, y equals x minus 5 is my other asymptote. Now, that's not a vertical or horizontal line. That's a diagonal line. So I'm going to graph that as an asymptote. Up 1 over 1. How about up 5, 2, 3, 4, 5. Just getting my x-intercept there so I can have a more accurate line. Okay, now it's going to be important to figure out, maybe where my y-intercept is, where my x-intercepts are, and any other points that I can figure out so I know where my parts of this equation, of this graph, are going to be. Are they going to be over here? they going to be in this region? Are they going to be in this region? Are they going to be in this region? That's the question we need to ask ourselves. Okay, so making an input-output table. Let's start by finding our y-intercept. So I plug 0 in for my y-intercept. Go back up here, plug 0 in, I get 8 over -1, which is -8. So if that is my y-intercept, then I know that this graph right here is going to be in this region, okay? All right, and then I look at my asymptotes and I say to myself, well, as x gets smaller, I have to follow this asymptote, right? And as x gets larger, I also have to follow this asymptote, okay? And I can't go up here. So I'm thinking to myself, it needs to kind of come over to this asymptote and come over to that asymptote. So it's going to be some kind of a parabola. Now you can check a whole bunch of points here. Like if I plug in -1, what's going to happen? Well, if I plug in -1, I end up getting, let's check it out, 1 plus 6, I'm just going to write that over here, plus 8 over -2. So I get about -7.5. Is that right? 14, 15 divided by -2. So let's see, at -1, I'm going to be around here. Oops. All right, and you could plug in a half, you could plug in a whole bunch of points, but basically this thing's going to be approaching both asymptotes. Okay, so something like that. And now I can do a similar thing over here. Maybe I can find my x-intercepts. So I can plug 0 in for y. Let's see, where can I do some work here? Now, if I take my denominator and multiply it to both sides, that's just going to become 0. So really, I can just do this. And then, let's see if I can factor this. Looks like that works. So I get that my x-intercepts are positive. Oh, not positive or negative. Are 4 and 2. So I got two solutions here. So at 2, I'm going to have an x-intercept. At 4, I'm going to have an x-intercept. I can even be more exact, figure out where 3 is. Right? That's going to be in between. That's going to be my vertex. So when I plug 3 in, what do I get? I get 9 minus 18 plus 8 over 2. So that's a -8 plus 8. That's going to be 0. No, that's not right. Oh, I'm sorry. That's -9 plus 8, which is -1, so -1/2. It's early in the morning when I'm doing this, so I haven't really woken up yet. Okay, so my parabola is going to look something like this, and it's going to make sure to follow these asymptotes. It's not going to cross the asymptotes. Let's do another one, number 32. Oops, I forgot the f of x. You should right away notice that if you divide this into this, you're going to break this down into x squared, right? Because you'll be dividing an x out. So you're going to be left with a parabola. So your asymptote is going to look like a parabola, one of your asymptotes. So doing that synthetic division, oops, that's positive 6. So I have a remainder of -4, and I'm left with a parabola here. I did this both times, didn't I? this should be, sorry, I recorded this once and then I recorded it again. I made the exact same mistake and I'm not sure why I keep doing that. This should be x plus 2, which allowed me to then divide by x equals negative 2. So you're probably confused as to why I did that, and now we just fixed it. Okay, sorry about that. So this should be x plus 2. All right, so look at what my slant asymptote is. Right here, this is going to be my asymptote, and that is a parabola. My other asymptote is going to be where x equals negative 2. Okay, so I'm going to start graphing this. Starting with my vertical asymptote at x equals negative 2. Okay. Next thing I'm going to want to do is graph my parabola asymptote, this asymptote right here. I should have just written one asymptote, not asymptotes. So a great way to deal with this might be to use, I'm thinking to myself, this might be an example where I don't have a calculator, and so I want to be able to do this by hand. If I had a calculator, obviously I just plug this in and figure out where my x-intercepts and my vertex are. But I'm going to go ahead and just look at this and try and do this by hand. So first of all, I know that my y-intercept is at negative 7. So I should have a dot at negative 7, a point at negative 7. Okay, and then to find my x-intercepts, maybe I'll use the quadratic formula. How about I'll do it right here? Nah, let's go down to the bottom. Nine plus 28, that's 37. Oh, I forgot to put it all over 2a, which is 2. Darn it. Okay. Let's put that over here. Okay. So I'm going to do an approximation here. This is really 3 plus or minus the square root. Let's approximate it to about 36, so it gives me numbers that are easy to work with. So I can say if that's 36, the square root of that is 6. So x is approximately, let's see, 9 divided by 2 is 4.5. And then negative 3 divided by 2 is negative 1.5. Okay, so we're going to have negative 1.5 as our x-intercept and 4.5. Here's 4, here's 5, so, oops, that's not 5. This is 5, so here's 4.5. Okay, now my vertex is going to be halfway between those two. So my vertex actually ends up being at 1.5. And then if I plug 1.5 back into my original equation, or here, this one, this works. Okay, if I plug it into, you need to plug it into this, into my asymptote. If I plug 1.5 in, I'm going to end up getting negative 9.25. So this is 1, 2. So approximately here. Now, if I had a hard time figuring out that halfway between these two numbers, these two x-intercepts is 1.5, then I could also do x equals negative b over 2a to find the x value of my vertex or my axis of symmetry. And I think I should get one more point here. This parabola is going to come up and it's going to touch the other asymptote. So I need to figure out where it touches the other asymptote. So the question is, when x is negative 2, what's my output? So I'm going to take my equation for the parabola, and I'm going to plug in negative 2. So when I plug in, let's see, you get negative 2 squared. Oops, I'm right down here. Minus 3 times negative 2, minus 7. So I think we get 3. Okay, so this is where the two asymptotes intersect. Okay, so I'm going to do my best to draw a really nice parabola here. Let's see, I'm going to start over here. Oh, that went out a little bit. Well, whatever. That was pretty sad. Okay, let me try that one more time. Let me come down to it. How about that? Something like that. Okay, and now the question is, where are the branches of this graph? So I can test some points. Maybe, oh, well, I have an idea. Why don't we figure out what our y-intercept is of this graph? So when I plug 0 in for x, right, so if I plug 0 in for x, I'm going to get negative 18 divided by 2, which is negative 9. Okay, so I'm going to have a negative y, or a y-intercept of negative 9 for this graph. That gives me an idea that this portion of the graph is going to be down here. Now look at these look at my asymptotes. This is craziness. So it's going to approach this asymptote. Now it's going to approach this asymptote, and then it's going to follow it. Okay, which is pretty. And you can plug in as many points to make this obvious to you, but I'm going to go ahead and just do something like this. They're approaching. They got to follow, okay? Sorry. Not dotted solid. Okay, so that's that branch. And then the other branch, well, maybe I could plug in like negative 3 and see where I should be. So if I plug in negative 3, oh boy, that gives me, let's see. So f of negative 3 is negative 27 minus 9 minus 39 minus 18 all over negative 3 plus 2. I'm just making sure I did my math right. Oh, this is going to be plus 39. Because if I plug in a negative, and then that's negative 18. Okay, so this right here gives me 30. So negative 27, positive 30 gives me 3, minus 18, that's negative 15. Is that right? That's not right. Over negative 1. Oh, that is right. So I get 15. So at negative 3, I'm going to be way up. Oh my goodness. Okay, so we're way the heck up here. But look at what's happening. It's going to have to, let's see, 3, 4, 5, 6, 7, 8, 9. Yeah, it's going to be way up there. So let's just approximate. I'm going to extend this a bit. Okay, but basically what you're going to end up with is this thing that also has to, you know that 3, 15, or sorry, negative 3, 15 is a point. Let's just pretend like that's 15. And then from there, it's going to approach this asymptote over here. It's going to come back around. It's going to approach this asymptote. So it's going to look something like that. And I'm just going to pretend that this ended up being 15. So I didn't do a very good job graphing that. I apologize. Okay, so there's our final graph. And then, of course, you can always punch this in your graphing calculator to check it.